Hello, Pooja madam.
Yes, sir.
Hello.
Yes, sir.
Okay, we will start.
Yeah, yeah. Fine. Yeah.
Good morning, everyone. Respected resource person, distinguished faculty member, dear participant, I am Meghna Gandhivarekar, Assistant Professor in DYPCET College of Engineering, Kolhapur. It's give me immense pleasure to extend a warm welcome to all of you to this faculty development program on next generation computing, generative AI, quantum computing, agentic AI, and emerging technology. Today's session is dedicated to one of the most essential aspects of modern research, that is, data analytics for research. In this era of data driven decision making, the ability to collect, analyze, visualize, and interpret data has become fundamental skill for every researcher and academician. In this session, our esteemed research person will guide us through the introduction to data analytics, providing a strong foundation for understanding how data support quality research. The session will further explore exploratory data analysis, enabling research to understand dataset through descriptive statistics and graphical techniques. It is my privilege to introduce today's speaker, Dr. Pooja Patil, an immense resource person with us, whose expertise and experience in this domain. Dr. Dr. Pooja Patil is an accomplished academician and computer science professional with over 13 years of combined experience in higher education and IT industries. She possesses a strong background in teaching, research, curriculum development, accreditation activities. Her expertise in artificial intelligence, machine learning, deep learning, cloud computing, data structure, and computer network. Dr. Pooja Patil has completed her PhD at DY Patil Agriculture Technical University, Tarsande. She holds a Master of Engineering degree in Computer Science and Engineering from Pune University and Bachelor of Engineering degree from Shivaji University with distinction. Her academic excellence is reflected in a multiple merit awards and consisting outstanding performance throughout her education journey. Dr. Pooja Patil currently serves as Assistant Professor at DY Patil College of Engineering and Technology, Kolhapur, with a total teaching experience of 9 years with the various institutes. Before joining the academia, she gained valuable industry experience as a senior software engineer at Tech Mahindra, Pune, and received the prestigious award Pat on the Back for her performance. She has published multiple research papers in reputed Scopus Index Journal and present paper at national and international conference. Additionally, she holds a registered research design patent titled with Hospital Occupancy Optimizing AI Devices. She has actively contributed to institute development by serving as a NBA Criteria 4 coordinator, NAT coordinator, CSI faculty coordinator, syllabus setter, and development department of training and placement officer. She has successfully organized many workshops, technical events, student development activities, and faculty development initiatives. Dr. Pooja Patil Madam demonstrates a balanced profile combining teaching excellence, impactful research, administrative capabilities, and industry explosion. On the behalf of all the faculty, all the participants, I extend a very warm welcome to Dr. Pooja Patil Madam. We are delighted to have you with us. Thank you for accepting our invitation. Without taking so much time, I request Madam to start today's session. Madam?
Yes, madam. Am I audible?
Yes, Madam, you are audible. Please start your session.
Okay, yeah. First of all, thank you, madam, for such a warm welcome. First of all, I would like to thank Department of Computer Science and Engineering of DYPCET College of Engineering and Technology, Kolhapur, for giving me opportunity to conduct this session. Let me share my screen. Yes, madam. Is my screen visible to everyone?
Yes, okay.
Yes, ma'am. Screen is visible.
Okay, yeah. Let's start with my today's presentation. Good morning, everyone. Today I'm going to give presentation on data analytics in research. So before we start with our actual contents, let me ask you some questions so that I just want to get how much idea do you have about the data analytics, so that with that information we can start with the actual contents of the data analytics. So let me ask you one question, or let's have one scenario, or let me ask you one question regarding the concepts of the data analytics. Suppose there are two researchers, for example, researcher A and researcher B. Okay. So researcher A collects data from that data. He makes the table. After creating the table or converting the data into structured format, he writes the conclusion based on his observations. Okay, so this is the way researcher A has done his analysis on the data. He has just collected the data and he has written, or he has created the table, and then he has written the conclusion based on his observation. Okay, now we'll move to the researcher B. He also collected the data, clears the data, applies some statistics, and build predictive model based on this, which actually supports this conclusion. Okay, now let me ask you one question. Now you have idea about what things has been done by researcher A and researcher B. So whose output will be more meaningful as per your opinion? You can write your answer in chat box. Both two researchers are there. They are doing their research. Both have collected the data, but they are using different methods. So researcher A has just collected the data, makes the table and writes the conclusion based on his observation. But researcher B has done some more processing on the data. He has used some statistical processes, some formulas. He has built the predictive model, and whatever conclusion he is getting, he has proof or he has evidence to conclude that output. Yeah. So I can get a response from Isha ma'am, Snehal ma'am, researcher B, right? Okay. So this is what, or I can say, this is my topic, which actually covers the points from for the data analytics. So researcher B has used concepts of data analytics. Okay, so we are going to see what is data, why data is important, what are the types of the data. Then we will see some of the or many techniques to do the analysis of the data. And then we will see multiple tests. For example, hypothesis test is there, ANOVA test is there, T test is there. Then we can go for the regression analysis, how the analysis can be done, and how we can reach to the conclusion. Because whenever you are writing any paper or whenever you are doing the research, every data or everything whatever you are doing, that should have some evidence, that should have some proof, right? So without any proof you cannot publish your data, you cannot publish your paper. Everything has to be tested, everything should have some background, or it has some values to support your evidence or to support your conclusion, right? So that is all about the today's topic, which is data analysis in research. Yeah. So these are the points I'm going to cover. Ma'am, is my screen visible and am I audible? Everything is all right?
Yes, yes, you are audible. Continue.
Okay, okay, yeah. So I'm going to cover these points: introduction to data, data set, data collection techniques, introduction to analytics in research. What do we mean by data analytics and types of it? Then we will start with the actual techniques for data analytics. So first one is exploratory data analysis, then statistical analysis for research, which contains many tests, like I've already told you, hypothesis test, ANOVA test, then regression analysis, and then interpretation of these statistical outputs for research publications. And then I'll tell you some of the AI tools through which you can do the analysis, or you can get some visualized data in terms of a graphs. You can pre-process the data. So we'll have 10 minutes of hands-on demonstration at the end of our session. Okay. Yeah. So first we'll start with data. Why data is very important. If you see this diagram, you can clearly see we are collecting the data from multiple sources. Okay, so in today's era, or in today's every activity, for example, you can consider educational activity, healthcare, manufacturing activity, you can go for the social media activities. In every aspect or in every categories, it will generate enormous amount of the data, right? So we are collecting the data from multiple sources. So you can see here data sources. It will be stored in a cloud. So we can see a cloud will be a central repository where we are storing the data, which has a big capacity to store huge amount of data in billions or millions, right? And then we can see here there are multiple techniques which are used to pre-process the data. Cleansing is there. Then after that you can aggregate the data, you can do the analysis, then you are transforming the data. Actually we are going to see all these concepts in detail, right? And then after doing analysis, there are some dashboards or there are some tools through which you can visualize the data in terms of multiple formats. Okay, so this diagram actually tells about how the data can be captured in any field. If you are doing research, the data is, I can say, it is a foundation for any researcher to go ahead with the further things. Without data you cannot prove anything. I mean, if you are doing a research, you are first, you will do the literature, or you will see what is existing data, who has done work on that. So again you are collecting the data, and based on that you are adding your inputs, your algorithm, your insights into that, again by adding the new data. So everything is related to data only. That's why data plays very important role in all these concepts, right? Let's move to the next slide. So what is data? So data, I can say it is a foundation of scientific discovery. It can be a engineering innovation. It can be foundation for AI. It can be foundation for product development, decision making, or in any formulation of a policy. Okay. So without data, I must say research is merely an opinion. So without data, your research does not have any meaning. Okay. So if your data is of good quality, then automatically it will reflect to your good kind of research, and it will directly impact a good quality thesis, good quality publications. Okay. So data collection and analysis and pre-processing data always lead to accurate results and meaningful insights into your conclusion at the end of your research. Okay. So in, you can see the definition. It refers to raw facts, observations, measurements, or recordings collected for analysis to answer research questions or test hypotheses. Okay. For example, data in, if you are considering the domain of computer science, you can consider data in terms of images. You can consider data in terms of a text documents or a source code, or if you are working on any network problem, then network packet can be considered as one of the type of a data. If you are dealing with the healthcare applications, then you will definitely work on a patient records, or you will take the patient's records in terms of a ECG signals or any test which has been prescribed by the doctor. So that can be considered as a data. Okay. And if you are dealing with any business related issues, for that, the sales report or monthly feedbacks of the customer or weekly feedback, yearly feedbacks. So all these terms can be considered as a data. Data, I can say it is raw fact or observations or measurements you have done through some experiments. You have observed the thing, you have done some experiments, and through that you have recorded the data or you have collected the data. Okay. So this is what data is all about. So data is, I can say it is a foundation for your research. If data is of good quality, it definitely directly impact to the good research and good or high quality publications, right? Till now, is this clear? Everybody is comfortable? Are you understanding me? Yes. I want this session to be interactive. If you have any questions, you can write in chat box. Yeah. Now let's move to the types of the data. I'm just first covering some basics of this so that you will get more clear idea how to do the analysis and all those things. So before that, you should have the clear understanding of the types of data collection methods, how the data can be collected, so that the further things will be more clearly understood by you. Okay. So types of data, here you can see there are two types, quantitative and qualitative data. As name signifies, quantitative means the data that can be measured with number. So quantity, as name suggests, it will have some numbers. For example, duration 2 hours, speed 120 kilometers per hour. So that will be considered as a quantity. The data which has the number, which that will be categorized into quantity. Qualitative analysis or qualitative data is nothing but in which we are going to deal with the categorical data. For example, suppose I have asked, are you interested in, have you completed your engineering? So I will get answer in terms of yes or no. So yes or no question answers will be considered as a categorical data. Okay. For example, does that patient has satisfied with the product quality? Yes, no, neutral. Or for example, how your emotions are now today. So it can be happy, sad, or we can say neutral. So if I'm writing my answer in terms of a description, then that can be considered as a qualitative data which does not have any number. Okay. Now again, this quantitative data is classified into discrete and continuous. So discrete, the whole number that can be broken. Okay, for example, number of items. Suppose there is one basket. In that basket, 5 apples are there. So this 5 apples are that 5 number cannot be broken into 5.2 or 5.1. 5 apples are there. That is the whole number. Okay, so this will be your discrete type of a data. And continuous means we can break down the data. For example, if you are measuring your height, if you are measuring your weight, so height can be, for example, 5 feet 2 inches, weight can be 50 kg 2 grams. Okay, so likewise you can segregate, or you can break down the things into two parts, so that can be considered as a continuous. Right, again, continuous data is divided into two parts, as you can see here: interval and ratio. Interval is numbers with the known differences, okay, such as time. So interval, for example, I'm conducting today's session within time span of 10 to 12. So that is nothing but the interval. So fixed amount of, or fixed difference. So 10 to 12 I'm going to conduct your session, right? So this is called as the interval. And ratio, we can consider ratio, like for example, it uses multiple arithmetic operations like multiplication, then addition, subtraction. For example, the weight of X student is twice more than weight of Y student. So I'm using here twice, thrice. So such kind of statements, whenever you are using such kind of statements, that will come under the category of ratio. Now let's move to the qualitative data. As already told you, it consists of only the theoretical or descriptive data or categorical data. It is again divided into two types: nominal and ordinal. Okay, nominal is, for example, data used for naming variables like hair color, eye color, or color of a fruit. So that can be considered as a nominal. And ordinal, in which I'm going to use some values to represent the data. For example, suppose I'm taking a feedback from the students, whether they are satisfied with the new teaching method. Okay, so I'm taking that feedback in terms of three parameters. For example, if they are happy, or they are unhappy, or neutral. I mean, they are okay with the new teaching methodology we are using to teach them. Okay, so now whatever answers I'm getting in terms of a description, for example, happy, neutral, unhappy, I'm going to allocate the number for that. So happy will be considered in terms of 1, neutral will be considered in terms of 2, and unhappy, for unhappy I'm going to use 3 number. Okay, so this is all about the types of the data, right? Let me move further. What is data set? Because whenever you are doing your research, data set is very important. So there is a difference between the data and data set. Okay, so data set, I can say, more structured version or tabular format or organized format, which can be used for further analysis or further processing. You cannot directly take data as it is, which will be in unstructured format, for further processes, because if you are using such kind of a data, you will get ambiguity in that, you will get or failure at the end of your model or at the end of your result. Accuracy will be decreased. So data has to be in good format, or it has to be of good quality or structured data. So data set, I can say, it is a structured collection of a data organized for analysis, visualization, or for it can be used for machine learning models. So in short, I can say data with proper organization and metadata. Metadata is nothing but data about the data. If I'm describing the data again, then that can be considered as a metadata. So all these, when I'm combining together, it comes to the data set. This is a quick, I can say, comparison between data and data set. So data will be an individual fact, but data set, it will be collection of a data. For example, I'm considering the percentage or marks of only one student, that can be single data. Data set, if I am taking marks of 1000 students and I'm writing or I'm maintaining one Excel sheet for that, then it can be considered as a data set. So in data, I'm going to have a row values, but in data set, it will be organized. Data will always be unprocessed, but data set is always be ready for the analysis. Data will be a single observation, and whenever I'm collecting the data from multiple resources, multiple parameters, then I'm going to get multiple observations, so that can be considered as a data set. Simple example, today's temperature is, for example, 35 degrees Celsius, so that will be a data which will indicate the today's weather. But if I'm considering the weather report or weather data of last 1 year, there it will have multiple records or multiple observations, so that can be considered as a data set. Okay, so till now we have seen what is data, why data matters a lot for research, types of the data, and difference between data and data set. Because as of today's topic is data analytics in research, so first we should know what is data, different types, and why it plays important role in research, right? Let me move further. So you can see here, you all must be aware about this process. Whenever you are doing any research, you are going to first refine your research goals, right? Then you have to find out the right data collection technique, how the data can be collected. There are multiple ways, we'll see it further, what are the different ways of data collection. Then design your data collection instruments, identify and access your data sources from where you are going to get the data. Once it is done, you will collect the data. That data will be unprocessed, that will be raw data. You have to organize and store the raw data. Then you have to clean it, and then you all those clean data, pre-processed data has to be given for the analysis of the data. So here comes our topic, which is data analysis. At the end, I can see here analyze and apply the data. So before that, all these processes are there. Data collection has to be there, then data has to be pre-processed, and then pre-processed data will be given for the analysis. So this whole process every researcher is going to follow for in his research. To start with this, so in literature review, we are collecting the data, we are visiting different sources, we are collecting the data, and then we are doing all these processes to do the pre-processing. Okay, now this is a simple we can say step by step method to collect and pre-process the data, and then we will go for the analysis of the data. Okay, now in this slide we are going to see how the data can be collected. Okay, so actually there are four main methods are there: interview, survey, observation, and focus group. Okay, now suppose if we are talking about the survey method, so in survey method what we are going to do, we will prepare one questionnaire in a fixed format. Okay, and then we will give that questionnaire to the participants in terms of a online, or I can make a hard copy of that, and I will distribute it to number of participants or number of sources from where I want to get the data. Suppose my research is related to the medical field, so I want to know how the processes are done to admit the patient in a hospital. So I want to take a feedback from the patients, whether they are satisfied with the manual process of admission in the hospital. Is there any delay in the admission process? What is their feedback or what is their opinion? Whether the treatment is getting delayed because of the admission process. So such type of questions I'm going to draft it. So that will have a fixed format, right? Number of questions will be fixed, and the number of answers, or you can give the drop down, or you can take it in a numerical format. I mean, yes or no, categorical data, or you can take your feedback from the patients in terms of a 1, 2, 3, strongly agree or disagree. Likewise, you can fix the format and give that questionnaire to multiple hospitals and the patient, those who are visiting those hospitals. Okay, so you can collect the data in terms of a survey or doing the questionnaire. Second one is interview. Interview will be in more depth because you are taking interview, or it will be one-to-one activity. So you will visit the hospital, you will try to reach to the patients, you will ask them questions directly, or you will take their convenient time, and at that time you and that patient will sit together, you will ask them questions, and you will go into deeper, and you will try to understand the opinion of that patient about the admission process of the hospital. So it will be unstructured. I mean, questions are not fixed. It depends on the answers patients giving to you. Your next question will be depends on the answer of the patient for the previous question, right? So for format will not be fixed. Okay, so the interviews will, if you want to go in a depth, then you can go for the interview process. If your format is fixed, you don't want to visit, you just want to share the format or share the questions to the participant because the participants or the resources are not reachable from your perspective, then you can give them questions to collect the data. Next one is focus group. Focus group is, suppose whenever you are doing a research, you want to take opinion or you want to take the perspective of other individual of your colleague, your senior members, or your guide. So you can sit together or your batchmates and take their perspective, or they take their opinion about your research topic, about your work, so that you will get different views or perspectives or opinions from everyone's angle, and it will definitely help you to process your data in a good way, or you will get multiple perspective of your research topic, and that will definitely help you to process further for your next uh, research activities. Okay, so focus group in which you will, a group of people will sit together, you will discuss an idea, you will take inputs from them, and you will work on that. Okay, and last step is observation, where you will not go to anybody, you will not discuss your research in a group, you will not make a questionnaire, but you will observe the things on your own. So rather than taking feedbacks from the patient, what I'll do, if my research related to the medical field or related to the admission process of the hospital, I'll directly visit the hospitals, I'll sit there for longer hours, and I'll observe the things, how patient comes, what process they are doing, how they are filling the forms, what is the overall process of the admission. So I'm going to observe on myself, right? And I'm not going to dependent on anybody. I'll observe the things. I'll, for example, I'll visit the multiple hospitals for a period of 1 month. I'll collect the data, and on that data I'll start doing the processing. Okay, so these are the different techniques through which you can collect the data. So I can say this data collection method depends upon what is your objective, what is your target population, which hospitals you are taking for your research. For example, if are you only focusing the hospitals in Kolhapur district, or you are taking it considering the hospitals within 2-3 districts, then it will be impossible for you to reach the hospitals outside the Kolhapur city, right? So for that you can use a questionnaire method, or you can ask the questions to them. So according to your target population, according to your sources, your objective, the data collection method is going to vary, right? Okay. Once the data has been collected, we are going to pre-process the data. So in pre-processing, multiple things are there. First one is we are going to have a data cleaning process. So in data cleaning, the missing values will be removed. We are going to correct the errors, remove the duplicate data, because sometimes what happen whenever we are taking a feedback from multiple uh, resources, someone will write answer in Marathi, someone will write answer in English, someone will not attempt all the questions, so some values will be missing, some values will have null values, right? Everybody is not going to follow the format that you are expecting, right? They are going to write or they are going to answer their questions according to their convenience, their level of understanding. So when you are collect this data, it will be in unstructured format, multiple ambiguities or null values, missing values will be there, right? So for example, if you are asking the age, someone will write in a number, someone will write in a words, right? So everything, every data will be in unstructured format. So you are going to clean the data first by removing the missing values, correct the errors, and you are going to duplicate the remove the duplicate records. After that, the data integration is there. That means suppose I visited 5 hospitals, I'm going to collect the data, clean the data, and then I'm going to integrate the data of all 5 hospitals together, and I'm going to maintain it as a data set for my further process. We have already studied what is data set. It is a proper organization of data in a proper format. Okay, so you are going to collect the data from all 5 hospitals and you are going to integrate all those data togetherly in one format. Then data transformation is there, in which you will do the normalization process or standardization process. Standardization, normalization means what? You are going to normalize the things in some scale or some range. For example, suppose patients are having some diseases or for example some symptoms like cold, cough, fever. So you will convert those descriptive data into numbers. For example, cold will be represented by 1, fever will be represented by 2. So you are going to transform the data in some format. For example, I'm using number system from 1 to 10. So all the diseases, all the symptoms will be represented in terms of number from ranging from 1 to 10. Okay, so that is transformation. So we are going to scale or we are going to standardize the data in a proper or in a one standard range, that is called as a transformation. Okay, and encoding the categorical data, if I am getting yes no like answers like yes no or all those things, I'm going to encode into numerical format, right? Next one is data reduction. Data reduction is you are removing the I can say the unnecessary features. If you are taking the data and multiple columns are there and out of that 1 2 columns are not important or not playing that much important role for your research, then directly you are going to remove that. You are reducing the data, because whatever data you are using for training the model, that data has to be of quality one. Okay, then and then only your model is going to predict the accurate results. And then again you can reduce the data size, or you can reduce the, or you can remove the unnecessary features. After that, the data will be validated and that pre-processed data is now ready for the analysis. Now here a topic comes, which is data analytics in research. Before that, all these processes are there. Okay, the data collection, then pre-processing, and after that your data is now ready for the analysis. Now let me move further. Okay, before that I just want to ask you or just want to share one story, or I can say uh, one scenario. Okay, for example, you are working in institute, okay, and you are developing machine learning model develop this model, which anybody tell? Can anybody type? You are developing a machine learning model to predict a student placement count or to place or for student placement. You are developing a machine learning model which will predict in this year how many students will get placed according to which data you are going to analyze this. I mean, which data you will collect for this. Can anybody tell? Yes, you're working in an institute, you are developing a machine learning model for student placement to calculate the student placement ratio, to calculate the student placement count for this year. Then which data you will need for this? Okay. Student CGPA, perfect. Student result, placement details, perfect. Right? Now, student, I can say student marks, CGPA, aptitude score. Example I'm taking. Okay. So multiple things that you are going to collect for this. Now, simply collecting these values will not be your research. Okay. So your research begins with asking some questions. Which questions you are going to ask? For example, which factor influence more for student placement? Secondly, we can predict the placement in coming years. Predict placement for coming years by looking past data. For that, you need to collect the past data of placements. For example, the placement of last 3 years. Which algorithm is going to perform better to do this model? Which algorithm will perform better and why? What is the relationship between student attendance, marks or CGPA, overall activities, how these parameters are going to relate with one another, which parameter is going to influence more for student placement, how I can collect the previous data, and by looking into the previous or past data of last 3 years of the placement, how I can predict for the placement count for the today's year, for this present year, which algorithm should I use for my research, which algorithm has already been designed and used to do this analysis, and which new thing should I add into that to have more weightage to my research. Okay, so whenever you are asking such questions or whenever you are doing this analysis, that comes is nothing but your data analysis in the research. Okay, now let's start with the data analytics part. So first one is, I'll just go through the definition of data analytics. It is the process of collecting, cleaning, organizing, analyzing and interpreting the data to discover useful patterns, draw meaningful conclusions and support better decision making. Okay, so you are collecting, cleaning, organizing and interpreting the data to discover or to visualize the data into more meaningful conclusions. Okay. Now I would like to give you the information about the types of the data analytics. You just go through this diagram. There are actually 4 types of the data analytics. I just want to let you know these types with the help of one example so that it will be more clearer to you. You just go through this. There are 4 types: descriptive, diagnostic, predictive, and prescriptive. Okay. In descriptive, we will ask the questions: what happened? In diagnostic, why did it happen? Predictive, what will happen? And prescriptive, how can we make it happen? Right? So I'll give you one good example so that these things will be clear to you. Okay? Suppose you are working as a data analyst in a geo company, for example. Okay. Now your boss has asked you to give, or he has a plan to launch new plan for the users. Okay. And for that he have asked you to give the data about the usages, how the normal, or how the, or what will be the usage pattern of the users. Okay. So we'll start collecting the data because now the new plan is going to launch in the market. So for that, you will see, first you will see the users usage pattern. Okay. So now you can see here, when you do the analysis, you will come to know that there are 3 usages. For example, minimum usage, for example, the elder people, the people, those whose age is within the range of, for example, 60 to 80, they are just using the WhatsApp to have a chat, or they are just visiting some of the websites. They are not spending lot of time in internet, so their usage is very minimum. Okay. Now second category is of moderate usage. So for example, daily consumption is 2 to 3 GB. So for example, the people, those who range in between 30 to 50 age group, so they can they are watching some of the videos on YouTube, they are visiting Facebook, Instagram, right? So their daily consumption is 2 to 3 GB. Now you have identified one more category wherein the daily consumption is more than 3 GB. For example, the younger people or younger generation, they are watching movies, they are watching web series, they are playing games. So their daily consumption is more than 3 GB. Okay. So when you are going to execute any of the new plan, you have to first identify the pattern of the usage from different categories of the users, so that you'll come to know that what should be my next plan, or what, how I can go ahead with the next plan according to the usage pattern. Okay. So here comes your analysis of the data. Now we'll move to the types of the data. Okay. Now descriptive analysis is first type of your data analysis. For example, if you're finding a total or overall revenue of last 3 months, and how is the growth, so that will be a descriptive. Suppose you have been asked to give the revenue for last 3 months, for example, January, February, March. So rather than taking a data and giving to your boss, that will not be feasible way. So what you will do, you will first collect the data of last 3 months. You will prepare, or you will pre-process the data, and then proper structured data can be visualized in terms of a graphs, so that that data can be given as a summary to your boss. So by looking into that summary, he will get an idea what is my revenue of last 3 months, rather than giving him a raw data which will be difficult for him to understand, right? So you have converted your data into tabular, into a graphical format. So here you can see the revenue of last 3 months. So here I can see the revenue in January month is little bit at lower side. Then in February first week, it is much higher side. Then it has been increased at the end of the Feb, and then again in March the revenue has been decreased. So I can see here increasing, and then after February I can see the declining graph, right? So that is called as a descriptive analysis. So I'm just finding and collecting the data and giving the description about the revenue of January, February, and March. Second one is diagnostic. Diagnosis is means you are asking the questions why there is decline in the month of March, right? So that is nothing but the diagnostic. So you will ask this question why there is decline or why there is less revenue in month of March. Which parameters affects it most, or which thing I need to improve from my side to increase my revenue. So here the analysis part comes in diagnostic analytics. Third type is what? Predictive analysis or predictive analytics. Suppose you have been given with the last revenue of last 5 years. For example, revenue of 2020, 21, 22, 23, and 24. And by looking into that, you will predict the revenue of present year for this month, January, February, March. This is called as a predictive analysis. So by looking into the past data, you will observe the things and then you will predict the revenue of the current year. Okay, so that is prediction, or we can say the predictive analysis. And prescriptive analysis, wherein you're going to find the relationship between the things. Prescriptive means what? As a boss or as a CEO of any company, always I look for to, or always I want to increase my revenue. Always I want to get good feedbacks from the customers. I want to be as a good competitor in the market. For that reason, which things or I can say which things should I do so that I can get more revenue. So I'm going to find the relationship, which parameters are directly proportional or directly dependent on or directly has effect or impact on the revenue of my company, right? So suppose I'm developing any of the product, then I'll put discounts on my products so that I can get more customers to which can visit or which can buy my products. I'll increase the marketing strategy, I'll improve my marketing strategies, I'll do more advertising so that my revenue will get increased. So I'm going to find the relationship between the things which will have a direct impact to my revenue, which is called as a prescriptive analytics. Okay, so with the help of these examples, I have explained you what is data analysis and the types of the data analysis. Is this clear till now? Yes.
Yes, ma'am.
Now we'll start with the actual technique, or I can say some of the analytical process or data analytical techniques which are used to conduct this analysis. So let's start with the yes, Meghna ma'am, am I audible?
Yes, ma'am.
Oh, yeah. Yeah. So first one is exploratory
You are
data.
not audible. Pooja, ma'am,
Yes.
you are not audible. You are not audible.
Hello.
Ma'am, you are not audible now.
Yes.
Okay.
Yeah. Am I audible,
Yes.
ma'am?
Yes,
Please
yes.
let me
Yes,
know in
ma'am.
between. Yeah. Please let me know in
Yes.
between if there are any issues. If my screen is not visible or there is some problem with my voice, then please let me know. Okay.
Okay, ma'am. Now
Yeah.
start.
Yeah. Okay. So we'll start with the actual techniques of the data analysis. So first one is exploratory data analysis. So in this technique, this technique is used to understand and summarize data. We are not going to conclude, or we are not going to predict anything. We are going to just summarize the things with the help of descriptive statistics. Okay. Every researcher has gone through all these processes, or the faculty member, those who are doing research right now, they have to do all these things in terms of calculating the mean, mode, median, calculating the standard deviation, variance. It is there, or it is must for every data, for every analysis of the data. So descriptive analysis or descriptive statistics is divided into measure of a central tendency, measure of variability, and measure of frequency distribution. We are going to see it one by one with the help of example so that it will be clear to you. We start with the measure of central tendency. You just keep in your mind exploratory data analysis is one thing which is used to summarize the data or to convert the raw data into some good format or to find out the properties of data, I can say. How what is the mean of the data, which point is the center point, how the data has differ from one another, uh, as how I can make the cluster, which type of data or which type of a groups, or I can say the which type of a data has similar features. So to find out all those things, to find the relationship between the data, I must find out all those things through which I can do this analysis, because we are doing analysis on data only. So for that we need to find out all those things. So first one is measure of central tendency. Okay, so it has been divided into three parts: mean, mode, and median. Okay, for example, you have taken a data set 734176. So in your data set you are having these many numbers. So as you all know, mean is taking average of all those numbers. So you are taking sum of these numbers divided by total number of observations. So 6 numbers are there, so you are taking mean or average of this. Most common data which has been find out, or the data which has occurred more frequently. Okay, so here in this I can say 7 number is has occurred 2 times. So most common value or mode of this is 7, and median is you are taking out the mid of your data set. Okay, so here for this thing you are going to first arrange data in ascending order or descending order, any order you have to follow, and then you have to find out the mid. Now here in this case there are actually it is even number, so total 6 numbers are there. So to find out the mid, I have taken the 6 and 4 two numbers, addition of these two numbers divided by 2. So I'll get mid of this, which will be 5. Okay, so this is the way I'm going to calculate the median, mode, and mean, which comes under your measures of central tendency. Next one is measures of here measure of variability, right? So we are talking about this. Measures of variability quantify the degree to which data points differ from each other and from central value. Okay, so why we are calculating these measures of variability? To find out how the data differs from each other. Are they different? Are they similar? How I can make the cluster or a group of similar data with similar features. So to do all these things we need to calculate the standard deviation and variance. So these questions will be answered with the help of this. Are the data points tightly clustered around the mean, or are they widely dispersed? How consistent or reliable are the observations? How much diversity or variation exists within the data set? Okay, so whenever I've collected the data, suppose patient feedbacks is there. So some patient will give a positive reply, some patient will give the feedback in very aggressive way, some patient will give you the reply in neutral way. So you have to do the analysis, you have to find out the mean or average of all those data, and you have to compare each and every data with mean value, so that you will come to know how the data has been variated or how the data is different from one another, and different at, I can say, what are the differences, or is there if there is in the data set, how it can be minimized so that no value should bias or no value should have more influence on the prediction model. So everything has to be standardized, everything has to be set on one data, same standardized scale, so that your predictive model will give you right answer. So now in measures of variability, or it is also called as a dispersion, we are going to have 4 techniques to calculate the range, variance, standard deviation, and interquartile range. So normal range, it is the simplest measure of variability calculated as the difference between maximum and minimum value in the data set. Suppose this is the example 5, 8, 12, 20, 25. So here maximum value is 25, minimum value is 5. So 25 minus 5 is 20. So that is called as a range. So how much, within which range this value exists. So 20 will be the range within which this value exists from 5 to 25. Variance and standard deviation is very much important in data analysis. In every calculations, we are using variance and standard deviations. So here variance, the formula is S square is equal to summation of x into x minus x bar square divided by n minus 1. X bar is your mean that you have calculated. Okay, so for example, these are the data values and this is the mean. X bar is the mean. So from each and every value, you are going to subtract the mean. So 17 minus 16 is 1, 15 minus 16 is minus 1, 16 minus 16 is 0. So from every data set value, you are going to subtract the mean and you will get these values for each and every data points or data values within your data set, right? Now you have to sum up, you have to do the summation of all those things and then you have to divide it with the n minus 1. N is your total number of observations. So how many data values are there? 1, 2, 3, 4, 5. So 5 minus 1 is 4. So you are going to calculate the variance, and standard deviation is square root of the variance will be your standard deviation. So whatever value you are going to get for variance, you are going to take the square root of your variance. So variance is actually tells about how or it will help you to measure how far each data value is from the mean. Okay, so once you calculated the mean, you will calculate or you will measure how each data point differs from the mean. Is there any major difference, or they are slightly, or they are close, they are having a close relationship with the one another. And standard deviation will tell you about the average spread of the data, how the data has been segregated or it has been distributed uh, across the whole area of your research. Okay, so that will be as your standard deviation. Then interquartile range is another technique. So here you can see it is actually used how spread out the middle 50% of the data. So you are going to identify, you are going to calculate the middle part, how it has been affected with the least and the highest value. Okay, so here first you are going to identify the middle of this data set. 5 is the middle. So this part, left side of the middle part will be Q1 and right part will be Q3. So you are going to minus the Q3 minus Q1 is equal to I mean the left part is the mid value is 5, left part is having values are 3, 4, 4. From this the middle value is 4, and for the right part 6, 8, 8, the middle value is again 8. So I'm going to subtract the middle of Q1 and middle of Q3, which is 4 and 8. So 8 minus 4 is 4. So actually this interquartile range is used to or to find out how spread out the values in the middle 50% of the data, and it should not be affected with the least and the highest value of the data. So we are going to concentrate on the middle part with the help of this IQR range. Okay, so this is called as a measures of variability and dispersion. Now, third point in EDA, that is exploratory data analysis, is measure of frequency distribution. So I can see here we are using multiple types of graphs. So bar graph is basically used to represent each and every category. So this each and every each bar represents a different category, and height of this bar shows the frequency. Okay. Next, pie chart, the entire circle will be considered as 100%. and each slice represent the category within its distribution. Okay, for example, 40% patients have replied as they are okay with the manual process of admission. 40% of the patients have replied that they are not okay with the manual process of the admission, and 20% are neutral. They are okay with both automated system and manual system. Okay, histogram, here no gaps are there. We are going to identify the data distribution, whether it is normal, skewed, or uniform. So no, without any gaps, we are going to club it together, and then we'll see what is the pattern, whether it is normal one, uniform one, or it is skewed one. Okay, and this is your frequency polygon. Okay, so data points, you are going to identify the data points, and then you will draw a graph which we'll call as a frequency polygon. So in measures of frequency distribution, you are going to represent the data in terms of various forms of the representation in terms of a graphs. Bar graph is there, pie chart is there, histogram is there, frequency polygon is there. So this is all about exploratory data analysis, in which we have covered these three types: measures of central tendency, measures of variability, and measures of frequency distribution. Now we'll move to the hypothesis part, which will be followed by two tests, t-test and ANOVA test, and then we'll go for the regression analysis. All these analysis comes under your data analytical part. You have to do this analysis in your research. Okay, let's start with statistical analysis for research, which has these points. First, we are going to see what is hypothesis. Okay, so hypothesis is nothing but we are going to make a statement uh, uh, about the relationship between two or more variable, and that can be tested through experiments, through observation, through analysis using sample data. So hypothesis cannot be built on population. Population is the whole area. For example, it's uh, each and every hospital. There are 80 specialty hospitals. We are nearby me hospital to work on that. So hypothesis built on the sample population. So hypothesis is so
Hello, ma'am. You are not audible. Ma'am, are you there? Ma'am, you are not audible. Please check your connection once again.
Hello, sir.
Yes, ma'am. Yes, ma'am. Now you are audible.
Okay. Actually, because of some network issue, I was disconnected.
Okay, no problem. You can continue.
Reshare my screen. Yeah.
Okay.
Just tell me, let me know whether my screen is visible. I'm going to
Yes,
share it.
sure.
Yeah. Yes, ma'am. Visible?
Yes, now it is. Yes. Now it is visible and it is audible also.
Okay. Thank you. Yeah. So we are actually discussing the types of the hypothesis. Null hypothesis, alternative hypothesis. So in null hypothesis, we are making a statement or we are building a statement that is there will not be any effect by introducing a new method. An alternative means an measurable effect by introducing a new method. Okay, so this hypothesis should be prepared before you start with the actual experiment, before you start doing the analysis. So this hypothesis needs to be proved with the help of some evidences. Okay, so you will start to prove this hypothesis, you will start collecting the evidence, you will start doing the analysis, you will start doing the experiments, and then at the end you will try to prove whether your null hypothesis has been accepted or rejected, or alternative hypothesis will be accepted or rejected. If alternative is accepted, by default null hypothesis will be rejected. If null hypothesis is accepted, then alternative will be rejected by default. Okay, so here we have seen this with the example. If I'm introducing a new algorithm, then the execution time will remain same. if we compared with the existing algorithm, that is my null hypothesis. If there is any change, if execution time is getting decreased by using new algorithm, then this is called as a alternative hypothesis. And third type is directional hypothesis. It shows the direction. Means if in this alternative we can say that mu1 and mu2 is not same, but which value is greater one? Suppose by introducing a new algorithm, my execution time is getting decreased, then it is called as a right tilt. And by introducing a new algorithm, if my execution time is getting increased, that means mu2 is greater, then I'm going to consider as a left tilt. So always, if I'm introducing any new thing, it should end up with the good accuracy, or execution time should be decreased. Then and then I can say there will be an improvement by introducing or by having my research. So right tailed will always lead to improvement, and left tail will always be at a worst case, because by introducing a new insights into this, you have you have a bad effect on the at the end of your research. Okay, so always you try to get a right tailed hypothesis. You would have to prove this right tailed hypothesis. Okay, so null hypothesis will be, I mean, there will not be any change by introducing a new algorithm. Okay, and alternative, there will be a difference between original value and the value that you have achieved through your research. So keep in your mind, hypothesis should be built at the beginning or before you start doing the experiments, before you start doing the observations, or before you start the doing analysis. And to prove this hypothesis, you need to collect the evidences, and then only you try to prove whether you have achieved the null hypothesis or alternative hypothesis. So for that, you need to make two statements for null and alternative hypothesis. The next term is type 1 and type 2 errors. Okay, so you should not get this type 1 on type 2 error. When I will get a type 1 error, that means in reality there is no difference. The new algorithm does not improve the execution time, but I'm concluding, after doing my analysis, I'm concluding that new algorithm improves the execution time, but in reality there is no improvement. If there is a contradiction, or there is we can say the hypothesis that I have built, for null hypothesis there will not be any difference, but at the end I'm getting a difference, that means I'm getting a type 1 error for null hypothesis. And suppose I'm getting no difference in reality, that means I'm matching with the null hypothetical statement, that is called as a correct decision. Okay, next, uh, suppose I have built alternative hypothesis that there will be a difference by introducing a new algorithm, and in reality also I am getting a difference in the predicted values, or in the accuracy I am getting a more or good values, or there is a difference between the existing algorithm and new algorithm that has been introduced, that means that is a correct decision. But suppose I am claiming that there will be a difference, but in reality there is no improvement, then it will lie into type 2 error, that is called as a false negative. Type 1 error is called as a false positive, and type 2 will be called as a false negative. Okay, so these are the two types. So always try to achieve, or your decisions has to be correct one. You either you have to prove null hypothesis or alternative hypothesis. Okay, so one error will be there. If you have proven null hypothesis, you will get type 2 error. If you have proven the alternative hypothesis, you will get type 1 error. Okay, now we will move to the t-test. So this is one of the tests that can be used to do the analysis of the data. So t-test is basically used to determine the difference between the two groups. Now I'm not considering, I'm not taking the data points individually, but I'm going to consider, or I'm going to see whether there is a difference between the two groups, whether there is a statistical difference or there is a difference by a chance. Okay. So to prove that, I am going to use a t-test. So everything that we are currently seeing is related to analysis of the data only. Either it can be related to the data points or it can be related to the groups of the data. Okay. I'm finding the relationship between the data, whether they are relevant, whether they are having the similarity, whether they are or there is variability, or whether there is a large gap or large difference between the data points. So I'm going to find out all those things with the help of this data analytical test. Okay. So now we'll see the t-test. Okay. So t-test is basically used to determine the difference between the means of a two groups. Okay. Whether they are statically different or they are different by chance. Okay. So here this diagram signifies these are the two groups. So I can see, is there any difference between these two groups or not? So when this t-test can be used, so at which point, or suppose I'm doing a research, whether should I go for t-test or ANOVA test, or I should do the regression analysis, that should I know. So how I can know this, or when the t-test can be used? Suppose I'm comparing two groups. For example, in patients, I'm taking two groups: the patient of the age group 30 to 50, and age group from 50 to 80. Okay, suppose I'm focusing only these two groups, my research is going to focus on these two groups only, then I can go for the t-test to compare these two groups, their feedbacks and all those things. Data is numerical, the data has to be continuous one. The sample size is relatively small. If you are taking too much the data for your research, then t-test will not be used. It should be generally less than 30. If you are working on a less amount of a data, then you can go for t-test, and it should be approximately normally distributed. Okay. So if these things are there in your research, then you can go for the t-test when you want to compare two groups. Not, you are not comparing the data points. Okay. Now I have taken one example, so that through that example, this t-test, you can you can understand the t-test, how it can be applied. Okay. Suppose there is a research problem, and engineering researchers wants to determine whether a new machine learning based teaching method improves the students' programming performance compared to the traditional teaching method. So right now, we all are using traditional teaching method. Suppose I have introduced in my research new machine learning based teaching method. So now I want to prove, or I want to determine whether that new teaching method has really improved the student programming performance or not. Okay. So I have divided into two groups. Traditional method. So I have collected the marks of students when I have applied the traditional method, and when I applied the AI based method to teach them, I have collected the marks. So for example, there are 5 students. I have taken sample of only 5 students. So here, these are the marks of the students when I've used the traditional method. And for the same students, I'm getting these marks if I move to or switch on to the AI based method. Right now, research question is that does the AI based teaching method significantly improves the programming score or not? Right. So I have collected the data and I have divided into two groups. Now I am going to make a hypothetical statement. So null hypothesis will be, I'll write, there will not be any significant difference in the average scores. So mu1 is equal to mu2. And alternative hypothesis, there will be significant difference in the average scores. So at the end, I'm going to get a significant difference for the students in the marks. Okay, so these two statements you can make before you start with the analysis. Now, this calculation of the mean and standard deviation comes here, that we have studied under the exploratory data analysis. Okay. So first I need to calculate the mean. So for traditional method, there are two methods, right? Traditional methods, we have collected the students' marks, and by using AI based method also, we have collected the marks. So for these two different groups, we are going to find out the mean. So here, what we are going to do, we will sum up all these marks divided by total number of samples, which are 5 students we have taken. So 5 will be there. So the marks we are getting, mean we are getting for the first group is 70, and for AI based method I am getting it is as a 77.8. And now we are going to calculate the difference between the means of these two groups. So 77.8 minus 70, which is 7.8. Now we are going to calculate the standard deviation. Why standard deviation is important? We are going to check how each data point differs from the mean of your cluster or mean of your group. So we have calculated the mean. Now we will check how each data point from each group differs from the mean. So for traditional method, I'm going to take mean, which is 70, and for every data value, I'm going to subtract this value from the mean. So 68 will be subtracted from the 70 because mean of the first group is 70. So 68 minus 70 is minus 2. So likewise, I have calculated for all the data points. 70 minus 70 is 0. 72 minus 70 is 2. So likewise, this every data point will be subtracted from the mean, and then I'm going to take the square of this. So minus 2 square will be 4, 0 will be 0, 2 will be 4. Likewise, the square will be calculated, and then all this I'm going to take as a summation of x minus x bar square. So this square I have already got here. I'm going to sum up all those things. 4 plus 4 plus 1 plus 1, which will be 10. 10 divided by n minus 1. So that is my standard deviation formula. N minus 1, n is total number of samples. 5 minus 1 is 4. So it will be 2.5. This is my variance, and standard deviation is square root of variance, which is square root of 2.5, which will be 1.581. Okay. So this is the way I have calculated the mean and standard deviation and variance. Now, this is for traditional method. Okay. This we have calculated for the traditional method. Similarly, we have applied the same thing for the AI based method. So for each data point, I have subtracted it with the mean. So what is the mean in AI based? It is 77.8 for the AI based method. So every data point will be subtracted from that, and I'm going to take a square of that, and then I'll calculate the standard deviation, which is 1.924. Okay. Now step 3 is, till now we have calculated the mean, standard deviation and variance for both the groups. Group A, in which traditional method is applied, and group B, in which AI based method is applied. Now we will see the t-test formula. So this is the formula for t-test. So here you can see t is equal to x1 bar minus x2 bar divided by square root of s1 square divided by n1 plus s2 square divided by n2. Now we'll put the values. This is the mean of first group, which is 70. x2 bar is mean of second group, and now in square root, s1 square is the standard deviations, it is 2.5. For second group, it is 3.7 divided by n1 n2. N1 is sample number of observation in group A, number of observations in group 2, so which are same 5. So by calculating this, I'm getting the value for t, which is minus 7. Okay, and then we need to calculate the degrees of freedom. Okay, so to calculate the degrees of freedom, df is equal to n1 plus n2 minus 2. So which will be 5 plus 5 minus 2. So I'm getting value for df is 8. Okay, now till now we have calculated the value for t and value for degrees of freedom. Now we will look up for the t table, okay, which is available online. You can check for the t table from where I can get the value for the t. Okay, so here I have already pasted this t table, so you can look for this. This is the value for the df, which is what, degree of freedom, which is 8. Okay, so I will go for df is equal to 8. So this is the df value 1 2 3 4 5 6 8, and this is the t value. So this row is having df value and column is having t value. So I have already got value for t and df. So for df I got the value as 8. So I'll straightly go to this. So last value is what? It is 0.0005. But I have already got the value for t, which is more than that value, which is 7. So I'm going to take this last value for tf is equal to 8. So which is what? It is 5.041. Okay. So which is greater than 0.005. So I'll just tell you. Okay. So this is already there. I mean, if the value that we have got for the p by looking into the t table, if it is less than 0.005, then we are going to reject it. If it is greater than 0.005, then we are going to reject the fail to reject the null hypothesis. Okay, so here we got the value for this one, which is less than 0.05. That's why we are going to reject the null hypothesis. That means what we have done at the beginning, we have developed or we have built the hypothetical statements. Then we have used analytical analysis by calculating the mean standard deviation for both the groups. Then we have calculated the t value, we have calculated the degree of freedom, and by looking into t table, I can get the value for p. If it is less than 0.05, then we are going to reject it. If it is greater than 0.005, then we are going to fail to reject. As we got the value for p, which is 0.0005, which is less than 0.05, so we are going to reject it. That means we have collected, we have done the analysis, and now we have reached to the conclusion to either accept the null hypothesis or to reject the null hypothesis. So with the statistics, I can say that we are going to reject the null hypothesis. That means AI based teaching method significantly improves the programming scores compared to the traditional method. As I am rejecting the null hypothesis, what is my null hypothesis? There will not be any difference if I am using AI based methods. As I am rejecting it, which by default tells that if I am using AI based teaching method, that definitely is going to improve the scores compared to the traditional method. So for every hypothetical statement, you have to do such kind of analysis to prove your point or to prove your statement by calculating all these statistics. Okay, so this is all about your t test. Now we can go for the second test, which is ANOVA. Are you getting everyone? Am I audible? Everything is clear? Yes? Can you please put in a chat box? Are you getting everyone? How the t test can be performed, in which case the t test can be performed? Yes, can anybody reply? Is everything going smoothly? Are you understanding me?
Okay, go ahead. No problem.
Yeah, okay, thank you. Okay, the next test is ANOVA test, which is analysis of variance. Okay, so it is used when you want to compare more than two groups. So three or more groups, if you want to compare, then we can go for the ANOVA test, which is analysis of variance. So here you can see in this diagram, there are three groups: group 1, group 2, and group 3. So here we are going to see the variability within the group and between the group, how the data points varies within the group and how the data values are going to differ between the groups. Okay, so there are actually three types: one-way ANOVA, two-way ANOVA, and repetitive measures ANOVA. Okay, so in one-way ANOVA, we are going to compare means across one factor with multiple groups. So there are three groups. So we'll take one factor or one parameter through which I can compare three groups. For example, comparing exam scores among three teaching methods. So exam score will be one factor that I'm going to compare with three teaching methods. So I'll use three different teaching methods and I'll try to compare what exam scores I'm getting by teaching these three different methods. I'm going to compare with that. Okay, in two-way ANOVA, instead of only using one factor, I'm going to use two independent factors to compare within the group. So along with the exam score, I'm going to use a gender on exam score. Okay, so I can add one extra factor to compare within these groups. And repetitive measures ANOVA, it will be used when same subjects are measured multiple times. For example, blood pressure measured before, during, and after treatment. Okay, so I'm going to take same object which can be measured multiple times. So blood pressure is one parameter which can be tested before, after, in between your meal, or it can be in between or before, after your treatment. Okay, so ANOVA t-test is used to compare only two groups. If you are having more than two groups, more than two clusters for your study, then you can go for the ANOVA, which is called as analysis of variance. Okay, now here how the hypothesis can be built, because you are going to have three mean. So mu1, mu2, and mu3. In t-test, you are having only two groups. That's why mu1 and mu2 are there. But in this, you are going to have three means for three groups. So in null hypothesis, you will make a statement like H0 is equal to mu1 is equal to mu2 is equal to mu3. And in alternative hypothesis, at least one group mean should be different. Okay, so then I can say that that teaching method has a direct impact on the exam scores. Okay, now what is the formula to calculate this ANOVA test? Okay, so the formula to calculate this ANOVA test is F is equal to variance between groups and variance within the groups. Okay, so we are going to see this again with the example so that it will be clear. So you just keep in your mind that for ANOVA test, F statistics will be used, and formula for this is variance between groups and variance within the group. Okay, now we will try to find out the value for this variance between group and within the group, right? Now again I have taken the example, and in engineering college wants to compare the effectiveness of teaching methods on student programming test scores. Suppose there are three groups. We have taken sample of 5 students. Now 3 groups are there. So for first group is for teaching method A, second group is for teaching method B, and third group is for teaching method C. I have taken the exam scores of all the students, and then now I want to compare it to prove whether my null hypothesis is going to be true or alternative hypothesis is going to be true, by using which formula? By using F statistics. Okay, so this is the formula. So for that I need to calculate the variance between the group and variance within the group. Now I am having this data points for all these 3 groups. I'll start calculating the same mean and standard deviations and everything. So how I have built the hypothesis? Null hypothesis will be will not be any significant difference among the scores. So all will be same, and alternative means at least one teaching method has a different mean. So first, for all the groups, I'm going to find out the mean. So for method A, I have calculated the mean. For method B, I have calculated the mean. So likewise, first group is having mean as 71.8. For method B, it is 81.8. And for method C, it is 90. Okay, now I'm going to calculate the grand mean. So whatever values I'm getting for this, it is 359, 409, and 450. So I'm going to sum up all those things and divided by 15. So total number of observations are 15, because 5 students are there in all for all methods. So A, B, C. So total number will be 15. So value or grand mean will be 81.2. Okay. Now after this, there are actually two formulas, sum of squares between the group and sum of squares within the group, which is called as SSB, sum of square between the group, and SSW, which is sum of square within the group. Okay. So what is the formula for SSB? It is summation of x bar I minus x bar. X bar is your whole mean that we have, group mean that we have calculated. Okay. Now for method A, I'm going to calculate n is total number of observations 5. So 71.8 is your mean of your group A minus x bar is group grand mean that we have calculated for all these three groups. So we get these values for method A, B and C. So now SSB is adding up all these things. So 441.8 plus 1.8 plus 387.2. So I'm getting this value 830.8. And second is calculating the sum of square within the group. So what is the formula? So here x minus x bar divide square. Okay. So for group A, here we are dealing with the each data point within the group. So all these three groups needs to be considered. This sum of squares between the group is for all these three groups A, B, C, and within the group I'm going to calculate it separately for group A, group B and group C. So for group A, I'm going to subtract each data point from the mean of that group. So I'm getting this value. For group B, if I'm subtracting each data point from the mean of the group B, then I'm going to get this value if I'm adding all those things. And for group C, I'm also getting the value as 10. Now, whatever value I'm getting, I'm going to sum up all those things for SW, that is sum of square within the group. So, which is 32.8 plus 32.8 plus 10, which is 75.6. Now, I got SSB and SSW, that is sum of square between the groups and within the groups. Now I'm having these two values. Okay. Now I'm going to calculate mean square between and mean square within. That is my final value for F statistics. Variance between the group and variance within the group. So variance between the group will be MSP and variance between the within the group will be MSW. So to calculate that, MSP is equal to SSB we have calculated divided by K minus 1, and for MSW it will be SSW divided by N minus K. Okay. So here what is this K? You have to first, SSB is what it is, 830.8, and before that we have calculated the degree of freedom, which is K minus 1. So between the group it is K minus 1. Three groups are there. So 3 minus 1 is 2. And within the group is N minus K is equal to total observation, total participants or total samples are 15 minus K. K is nothing but your number of groups, which is 3. So 15 minus 3 is equal to 12. So these values I'm going to use here to calculate the MSP and MSW. Now I'm having MSP and MSW, which I'm going to put in F statistics. So I got the final value, which is 65.94. Now again, as we have checked for the T table, similarly we are going to have F table for the ANOVA test. So you can just look for this value with the help of degree of freedom, and then you can compare this value with this is I mean 3.89. If these two values like we have calculated for the P value in the T table, if the value that we have got for the P, if it is less than 0.05, then we are going to reject the hypothesis. Similarly here we are going to compare for the F statistics. So here F critical will be compared with the 3.89. If it is greater than 3.89, that means we are going to reject the null hypothesis, because we got the value for F is 65.94, which is greater than 3.89. So we are going to reject it. If it is lesser, then we are going to accept the null hypothesis. Okay. So this is the proof, or this is the analysis we have done to either accept the null hypothesis or to reject the null hypothesis. Okay. So keep in your mind, t-test is used to compare 2 groups and ANOVA is used to compare the 3 groups. Okay. Now, with simple example, I'm going to do this regression analysis. So regression analysis, I can say it is a part of machine learning algorithm. So wherein we are going to find out the relationship between the dependent variable and or one or more independent variable. Okay. So for example, the equation of the regression analysis is y is equal to mx plus b. So there will be one independent and there will be one dependent variable. So in a dependent variable is always going to be dependent on the independent variable. So we will try to understand how changes in one variable influence the another. So it is used for prediction and the decision making. So when this regression analysis can be used, in which scenario researcher can go for the regression analysis? When you want to predict the future outcome, identifying the factors affecting the result, final result. If you want to measure a relationship between the dependent and independent variable, and support decision making with the data, and with the help of that you are going to build a mathematical model for the prediction. Okay, so you will have a x-axis, y-axis. You are going to build this equation y is equal to mx plus b, and there will be a slope. When you find out the data points, you will get a slope, and from that you will try to build this predictive model for the regression analysis. Okay, so for example, I've taken here one example. Does study time improve students' programming marks? So here variable, independent variable and independent variable, X and Y are there. So study hours will be independent, but programming marks will be dependent on the study hours. If I study for 2 hours, I'll get marks according to that. If I'm going to increase my study hours, I'm going to get good marks. I mean, my marks will be improved. So dependent variable is marks, which will be dependent on the study hours. So independent variable is called as a, and dependent variable is effect, or it is called as a response. There are types: simple linear regression, where you are going to consider only one independent variable. In multiple regression, you will go for 2 or more independent variables. So along with the study hours, you can take attendance, you can take previous CGPA. So all together are having impact on the marks. And logistic regression is dependent variable is categorical. For example, that student is pass or fail, yes or no, right? So such kind of answers you can consider as a categorical for the logistic regression. Okay, so here I have taken a simple example for the regression, so that how the regression can be done, you will get an idea for this. So this is a data set. 5 students are there, A, B, C, D, E. Study hours, for example, A students has studied for 2 hours, B student has studied for 4 hours. According to that, their marks are visible here. So with the help of this, I have plotted the graph. X-axis will have study hours and y-axis will have marks. And according to that, I have here pointed the data points according to these values. So we observe that what is the relationship between X and Y. As X increases, as study hours increases, our marks are going to increase. So I can say there is a positive linear relationship between study hours and marks. Okay. So what is my equation for linear regression is y is equal to a plus bx. Okay. So what is y? That is a predicted value. I'm going to predict this value with the help of a, b, and x. X is what is independent variable. In our case, it will be study hours. A is intercept and B is slope. Okay. So in our case, A is 40. For example, we can say intercept is the point from where you are going to start your slope. So here 40 will be your passing mark. So I can consider A will be my intercept. And B is a slope. Slope is a regression coefficient, which tells about how much marks increase in every 1 hour. So every 1 hour I can see there will be increase of 5 points. So 5 will be my B, which is called as a regression coefficient. So you can see here, if I study for 2 hours, I got 50. If I study for 4 hours, I can get 60 marks. So if I study for 3 hours, marks will be 55. So at in for every increase in 1 hour, the marks will be increased by 5. So my regression coefficient will be 5. And intercept is from where I can start my slope. Okay, so that will be here I can consider as it is as a 40. So this is the way you can build your regression model, and you can put your values and you can predict the value for y. So y is your study hours and x is sorry, y is your programming scores and x is your study hours. Okay, and a and b you need to calculate according to your data values, according to your the data, or according to your x and y values. The a and b values can be calculated. Okay, okay, yeah. So till now we have seen uh, what is data, what is data set, data, different data collection methods. Then we have seen the pre-processing techniques, what is data analytics, what types of data analytics. And then we have seen multiple techniques through which the data can be analyzed. For example, EDA technique is there, exploratory data analysis. Then we have seen the t-test, then we have seen the ANOVA test, and then we have seen the regression analysis. So all these techniques can be used, but out of this anyone can be chosen according to your research objective, according to your work of a direction, then how the data points has been collected, whether these are in a groups or these are separate one, how the dependency is there, how is the variance, how much the data has been variated from each other. So you ask these questions yourself and try to find out which analysis tool can be used to do all this analysis to prove your hypothesis. Okay, next point is I just want to tell you, whenever you are publishing your paper, whenever you are writing your results, these interpretations of statistical outputs, how it can be written for your report, in your report or in your research publications. Okay, so interpreting statistical outputs correctly is very essential, because journal expects you to explain what the statistical results mean, not just the numbers. So you cannot directly write the value for t, value for f statistics, value for p, value for hypothesis. Okay, so you should have that evidence, or you should prove how you have calculated these values in your paper, then and then only it will be a meaningful one. Okay, so a simple we can say questions you can ask to yourself whenever you are doing this: which test you have performed in your research, whether you have used t-test, whether you have ANOVA test, or whether you have regression test used. Is the result statistically significant? Check the p-value. According to the p-value, you can check, is there any statistically difference, or is there any difference by chance? Okay, so if p-value is less than 0.05, that means you are going to reject the null hypothesis. That means you have statistically significant results. Okay, so you check for these values. Then you can ask how strong is the relationship. You can check for the r square. This method in regression analysis, you can go for these values, r square and the effect size. Then what is the practical meaning? Does it improve the performance by adding the new algorithm, by adding the new features, whether your research has helped to improve the performance of existing system or not? And then state the conclusion. Either you have to conclude by accepting or rejecting the hypothesis. And to do all these things, you have to prove, or you have to give all these values for t-test, p-values, ANOVA, r-square. You have to prove these values, then and then only you can go, or you can check for the whether how you can accept or reject the hypothesis. These are some statistical terms I have clubbed together, their meaning and their interpretation. So just want to club it together here only. So mean, we have calculated the mean, which is average of all data points. Why it is important? What is the interpretation? Higher mean, which indicates better average performance. If you are getting higher mean or higher average, that means your performance is better. If you are standard deviation, why we are using it? To find out the spread of the data, how the data has been scattered or how the data has been distributed across the area. Okay, so if you are getting smaller ST, which indicates more consistent data. Okay, more standard deviation means what? More value for the standard deviation means your data is not consistent. It is spread more. It is morely distributed across the area. So always try to achieve the standard deviation at lower side. Then t value, when you are comparing the two groups, larger t value suggests that the stronger evidence against the null hypothesis. Okay, that means you are going to prove the null hypothesis. F value, if you want to compare between multiple groups, then go for the F values. If F value is greater, that means there is a variation, a large variation between the group rather than within the group. So there will be more variation within the group. P value is probability of observing the results if the null hypothesis is true. So if P's value is less than 0.05, which indicates there is a statistical significance. R square we are using for regression model. So if R square is more, then your model is fit to do any kind of a analysis or prediction, and definitely you will get more accurate results. Beta is regression coefficient, and then confidence interval, which is not, I mean, a part of this right now. So you just focus on this mean, standard deviation, t value, f value, p value, r square, and beta. Okay, so with this I would like to conclude that key data analytics is powerful tool that helps researcher to transform raw data into meaningful insights. By selecting the appropriate analytical techniques and interpreting statistical results correctly, we can make research more reliable, accurate, and impactful. Okay, so always go for this techniques of analysis and converting the raw data into meaningful insights, and try to prove or interpret the statistical results correctly, which will always have lead to a good research, good publications, or reliable and accurate and impactful research for your project. Okay, so this is the way we have seen or gone through all the techniques and data analytical tools and processes. So I'll just explore in 5 minutes what the two techniques or two tools are there in which we can attach our file and do the analysis. So if you are there, you can just go to there. I'll just let you know there are two tools, AI tools, which will help you to clean your data, to help to represent your data in dashboards. Okay, so first technique is Julius AI. Okay, so when you type the Julius AI, you can get link like this. So simply a chat box is there. Here you can attach your file, Excel file, which has your data set. If you want to clean it, you can do it. So for example, I have already have one file.
Pooja ma'am.
Okay.
Pooja.
Yes.
Your screen is not visible.
Okay, I'll let you just check.
Yes, yes.
Yeah.
Only PPT is shown. Whatever you failed for the Julius is not displayed.
Okay, okay, okay. Let me reshare my screen once again. Yeah. Oh, yes, madam. Is it visible now?
Yes, ma'am, visible.
Okay, okay. Yeah. Okay, now you can just Google it, Julius AI. Once you type it, there will be a link. You just click on that link and you will go to this platform, which is Julius AI. So here you can attach your report. You just click on plus button. So here I have already have employee salary details of 100 records. So I've uploaded that file. Yeah. So here you can give the commands. For example, clean and pre-process the data. So along with the code, it will give you just click on this arrow. So this Excel file will be uploaded here. Will generate the code. Yeah, and it will give you the pre-processed file, clean file, and along with that, it will give you the summary of this data. Okay, so here you can see how many rows are there, columns are there. Have they been matched with this? Already, this file has been. I mean, there is no any null record or ambiguity, so that's why they have not. It has not represented. But if your file has some null values and ambiguities, it will show that how many null values have been uh, removed, how many duplicate values have been removed. Okay, and after that it will give you this clean file. Okay, now suppose I want to have to show some graphs, graphical, the presentation in graphical format. So suppose, just a second, I have prompt already there. So I can give this prompt. So this is my prompt. Analyze the employee salary data set. So this is the employee salary data set. Provide the descriptive statistics for basic salary and gross salary. Calculate the mean, median, minimum, max, range, standard deviation, and variance. So if I give such kind of a prompt, it will again take this file, do all the analysis, and it will give you the details along with the code for all these values. And along with this graph. Okay, so salary distribution with the help of, I mean, here amount is there, basic salary is there, and gross salary is there. And here I can see with the help of basic salary, because there are two columns, basic salary and gross salary. So for these two columns, it has calculated me, given me the mean, median, minimum, max, range, standard deviation, and variance. And you can see the code also here. Okay. Suppose again, I want analyze the employee salary dataset and create appropriate visualization and generate a bar chart showing the average gross salary by department. So by department, I just want to create or visualize this dataset by using a bar chart. Okay. Let me add with another group. For more details, I mean, you have to take the further plans, but I'll sign in with some another account so that I can show you some basic things. There is one more tool is there, which is called as Formula Board. This is similar as your Julius AI. It is also used to analyze and do all this kind of analysis. So you can get started for free. If you want to use it for uh, more purpose, then you can take a plan for this. So I'll just use this same user journey is there. You have to upload the file. Okay. Okay, actually the service of this formula board has been down. Let's try with the Julius. Let me check once again. Give me 2 minutes. I'm actually logging with another email ID so that I can show you 2-3 more prompts how it can be used. Then we will stop because it has some limited usage.
Hello. Today's session's feedback and quiz is shared in your chat. Meanwhile, you people go with your feedback as well as chat preparation. Meanwhile, I'm requesting to all participants, if you are having any doubt or any questions, so please mention in the chat also.
Yeah, here you can see the Excel sheet has been uploaded, and I'm analyzing. I'm giving this prompt that I want a bar chart showing the average gross salary by the department. So here you can see these many departments are there: R&D, sales, IT, HR, finance, and these are the gross salaries. So according to the department, I can see the bar graph. Okay, so similarly you can go for, I'll just show you one more pie chart, then we'll stop. Similarly, you can put a prompt so that directly your data can be cleaned, pre-processed, your data can be visualized. You can get all the values for mean, median, all those values can be given with the summary. So the beauty of these AI tools are the codes are there, and along with that you will get a summary and then the graphs. So here percentage of employees by department. So here you can see this. So these are the different departments, and according to their salaries I can see the percentage of employees by department. So how many employees are there? So 23% are in R&D, 11% employees are in sales. So likewise I can see the bar chart. Okay, in pie chart. Okay, again, suppose I want to show the top 10 employees with the highest gross salary with the horizontal bar graph. Okay, so likewise, I mean, you can do all these things. If you want to do more analysis, you can take the plan, paid plan. So more options are there. There are multiple types for the visualization. Multiple options are there. I mean, library data connectors. You can write your codes here, can connect your data to the database. So everything is there. If you want to do your analysis for your research, then you can go for this such kind of a tools, which is, for example, Julius AI and Formula Board. So these tools are there. So directly they are giving you this kind of a graph. So here I can see the horizontal bar graph for top 10 employees by gross salary. Okay. So likewise, you can do this analysis for the by using this. Okay, sir and ma'am, I'm done with my presentation. If there are any questions, you can put it on a chat box so that I can clarify these questions.
Okay, thank you, ma'am. As we come to end of the morning session on data analytics in research, I would like to express my sincere gratitude to our esteemed resource person for sharing valuable knowledge, practical insight of data analytics in research. Our session has enhanced our understanding of how data-driven techniques can improve the quality and impact of research. Thank you once again to everyone for your valuable time and participation. We look forward to meeting you in our next session. Before that, I request all the participants, please turn on your camera for photo. I request all the participants, please turn on your camera. Once again, I request all the participants, please turn on your camera.
Pooja madam, stop sharing
Yes,
your
sir.
screen.
Yeah.
Okay, thank you everyone. So dear participant, there is one notice for you. The second, the last session, probably from this FDP, will be start sharp at at 2 p.m. So everybody is requested to join on a time with connected with our validatory function. So it is must or it is compulsory to attend the validatory function from 4 p.m. onwards, 4 to 4:30. Thank you very much. Now we can leave now.